I'm going to go back to my workflow. And up here, I'm going to hit Hosted API. I'm going to choose dedicated deployment. We can take our yard management server and then paste it into that same code snippet we had earlier. And then we can run our code again. The code's the same. All that's changed is the infrastructure. So we're making a request to yard management.workflow.cloud, and then we get the same response back.
So you have a use case and you've trained a vision model to help you with that use case. Now the question is, where are you going to deploy that model so that you can get up and running? Well, my name is Patrick.
And I'm James.
Today, we're going to talk about how to deploy your computer vision models in the cloud. You may have tried to create your own cloud inference environment yourself in the past. And if you have, you probably realized that there are a lot more steps than you might have realized. From the computing aspect, you'll need to provision GPUs, which isn't always a super easy task to accomplish, especially with them in high demand these days from all of the cloud providers. You'll need to create your operating system, virtual machines, your orchestration layer for handling things like auto scaling, clustering to ensure availability, load balancing between different GPUs or CPUs. And then finally, you'll need the software to perform inference on your imagery using your computer vision model. And underneath all of these things, you'll need to devote time and resources to security, administering software updates, and then dependencies where, if you need to update one piece of this puzzle, you may find that you're going to have to update other pieces, and then that can result in a ballet that you need to coordinate between updates when you can take certain things offline, creating alternative places to run your inference so that you won't need to experience any downtime. Now, as you might guess, this can consume a lot of time, resources, and expertise, and also might not even get you the best results because this solution may not be perfectly optimized for computer vision applications. At Roboflow, our mission is to make computer vision technology more easily accessible for individuals and businesses of all sizes. And that's why we have the Roboflow Cloud infrastructure, where we took all of those puzzle pieces, all of those provisioning and management tasks that we just reviewed, and then we're handling them for you so that you don't have to worry about that whole ballet that I just talked about. You can concentrate on getting the best computer vision model and creating the best application to serve that model for your needs. And specifically within the Roboflow Cloud offering, there are 3 different options for performing inference that we're going to be taking a look at today. The Serverless API, then the dedicated deployment, and then batch processing. The first one that we're going to look at is Serverless API, and for that, I'm going to hand it over to James.
If you've ever built any software application, you're probably used to the idea of plugging in an API somewhere in your system, whether it be using something to send an SMS message or trigger a webhook or whatever that service is, calling an API. And when I'm building a computer vision application, oftentimes I want to get started quickly. I want to integrate. I want to take the image data that I have, integrate my model into my application, and be part of a richer flow of business logic or whatever it is that I'm building. And that's where the serverless API comes in handy. And I'm going to do a demo showing how to go from vision model all the way to inference results in just a minute or two. And with that in mind, I am going to share Roboflow workflows. And Roboflow workflows allows you to not only run inference on vision models. In this case, we'll be looking at a yard management system, a model that detects shipping containers, IDs, and various other things. And we're assembling logic on top of that. So usually, I would write Python for this sort of thing, but here I can literally just add the blocks that I want, piece it together, and then run Python code to kind of get my output from this. And so this workflow run my detection models, find shipping containers, crop out all the containers, run OCR, and then also show all the detections. It's a lot of work, and you can do this all with a serverless API, which is to say, even if we're doing multiple step vision workflows, run it on serverless API, get a JSON response, use that JSON to power your business logic, your application, whether it's something that's running kind of a web application, backend, front end, wherever it is, you can plug in your API and get things to work. And so with that said, deploying, I've got a code snippet right here on the right. And this code snippet allows me to run my workflow. Firstly, I say, I want to use serverless. I plug in my Roboflow API key, and then I call the workflow that I've built. And I can have the ID there, and I say whatever my inputs are. So that could be an image, it could be multiple images, it could be text prompts if I'm using a multimodal model like SAM3, whatever the inputs are. And then I'll get the response. And to get this code snippet, I just hit deploy, I choose images, integrate with my app, and then I get a code snippet, Python, JavaScript, whatever you kind of need for your application. And so with that, over here, I've got my codes. I'm going to run my workflow on this example of a shipping container. And we can see here, there's kind of an ID here. There's a few more IDs, but this ID is the one we've trained. So we're training to get these horizontal IDs. And we want to read these. And so let's say the person in the truck's just taking a photo on their phone. We want to process this to get that in our inventory management system. We can run our workflow like this. Web request is going to be made, API is going to process, model is going to be loaded into memory on our serverless, and then we will get a response that contains our OCR. And you can see here, we get the result from our model here, this JPHU 307527. And that's it. We detected shipping containers, we got their IDs, and we kind of have that in a programmatically understandable way. Now, this is serverless. And as with any serverless API, it scales up and down as needed. So if I've got 10 different clients and been making requests to the clouds, that's going to work just fine. We see kind of the ability to run consistently high throughput on those clients too. And so whether you're running a single kind of backend, or whether you've got a large application that needs to be running dozens of inferences a second, you can rely on your serverless infrastructure to spin up and spin down, and you'll pay for the compute you use on that. Another option that you might look at is dedicated deployments. And with dedicated deployments, you're able to provision cloud infrastructure for use in deploying your models. And dedicated deployments can run those same workflows that I was talking about earlier, but have a couple other properties that we should get into. And with serverless, as if you've worked with serverless API in the past, you'll know compute resources are allocated when you make the requests, which is ideal if you have workloads where you don't know how many requests are going to be coming in. They might be sporadic. You might have a backend that's just kind of taking in requests from clients, the server's processing it, and so on. But you may also have workloads that are more predictable, that are more consistent. One example might be like this yard management application may only need to be in operation from 9 to 5, and there may be a consistent workload and stream of images that are coming in throughout the day. And so you don't want to have to use a serverless API where models are constantly being loaded into memory, and that's taking 100, 200 milliseconds, whatever that may be, depending on the size of your model. And you want infrastructure that just has your models already there, ready to use. And so with that, I'm going to demo our dedicated deployments. And you might be thinking, okay, am I going to need to spin up a server? The answer is, yeah, but kind of. And it's not as much work as you think. And so when you're in Roboflow, we've got our workflow here that allows us to run our model. We can go into our deployments tab in Roboflow, and we can create a dedicated deployment. And this is going to be a cloud server, CPU or GPU that's specifically for you. And so when you call a workflow, your model will be loaded into memory, ready to serve all your requests. And you can also run multiple dedicated deployments too, and have those also scale. So you have similar properties of scaling if you are operating an application that has high volume. Now, if you've ever used GCP, you might be thinking, okay, so we're going to fill out like 4 pages of things. We have to choose our disk image, disk size, and so on. Well, part of our kind of vision for dedicated deployments is keep it simple. And so we will hit new deployment and we'll get asked to give our project a name. So we could say something like shipping. And then we can choose between GPU and CPU. And for a development workflow, we can choose development and get a deployment that will expire, which is ideal for testing our workflows. And once we're done, that'll kind of spin down after the time, or production. And when we choose production, then we start to get more options. So do we want to enable auto scaling? Do we want auto pausing? And those are helpful for both that scale and meeting requests, and also for making sure that your kind of costs are in check with auto pausing. So let's say shipping, we'll choose development and we'll choose a CPU since we don't really need a GPU to run our model. We can hit creating deployment, and then that's just going to start in the background. Now, I've prepared a dedicated deployment a bit earlier. The provisioning times vary. That could be a minute, could be 10, depending on the configuration you've chosen. I'm going to go back to my workflow, and up here, I'm going to hit Toasted API. I'm going to choose dedicated deployment. And look, our shipping one's already ready. But I've got a yard management one here, which I'll connect to. And then this is going to allow us to actually test our workflow in the web browser with our dedicated deployment, or we can take our yard management server and then paste it into that same code snippet we had earlier. And then we can run our code again. And so here, the API is the same, the code's the same. All that's changed is the infrastructure. So we're making a request to yard management or workflow.cloud, and then we get the same response back. And so with that, we've provisioned a dedicated deployment specifically for our use cases that has our model loaded in memory, ready to go. As we add more models, they're going to be loaded into memory too. And so whether we're running a workflow that has one model or indeed 5 different models, you could have all those loaded in memory, ready to go. Whereas with serverless, all those models would have to be loaded in memory every time. And there would be an additional kind of latency cost to be had there. So that's dedicated deployments, and I'll hand it back to Patrick to talk through batch processing.
So what you just saw from James with serverless and dedicated, the idea with those two inference options in the cloud is that they're great for situations where you need, let's say, real-time or synchronous processing. You have an ongoing application that you're using regularly, and you want to, in real time, submit your images to be processed. That might be imagery or videos, and then apply your computer vision models immediately and get a response back immediately. Batch processing is a little bit different, as you can tell from the name. If you have a situation where you need your data to be processed, but you can wait for those images or videos to be processed in batches, then this can be the ideal solution for you, because we're able to optimize the resource allocation after you submit the batch processing job, and then find the most efficient way for it to be processed computationally, which results in a lower cost. And I'm going to take a look at how you can create a batch processing job. All right, so over here, I have a video which is taken from a drone that is flying over an intermodal shipping yard. And today I'm using this example of drone footage for batch processing because I think that that is a common use case we see for batch processing, where you have a drone flying over a certain place where you want to take inventory of certain assets, or perhaps you want to inspect the condition of assets. Now, with a drone, you won't have the computing power on board to run your computer vision model, perhaps. So your workflow would look like you fly the drone, you collect your imagery, and then when the drone comes back, you can start your batch processing job to analyze the footage that you just collected. So that's my idea here. And before this, I created a computer vision model that is able to detect those stall numbers that are in the video that you just saw. And for the sake of this demo, what I'm going to do is just visualize the bounding box and visualize the labels. That's the workflow that you can see here. To help you understand where we're going for, I can here test this whole workflow over here. I can hit run. And what's happening right now is I'm just testing out my model to make sure that it works correctly on my imagery. There is one of the frames from my video. Now from here, let's say that my drone just came back and I have a video file that I want to process with batch processing. I can go to deploy, and here I'm going to either choose if I have images or videos. In this case, I have a video that I'd like to process. Here, live video, recorded video, I'm going to go here for the batch processing option, and I'm going to come up here to run the batch processing option. And then from here, you're going to have a couple different options presented to you. The first thing is you can decide which data you want to process. There might be some previous uploads that you have worked on and you just want to reprocess those. I can upload images or I can upload some videos. Today, I'm going to start off by uploading a video. Like, let's say that I have this one of flying over the intermodal shipping yard that I just looked at. And then there's going to be a couple options here in terms of the processing speed that you need. You can create a name and you'll have your job ID. And then over here in advanced, again, you can decide if you want a CPU or a GPU. You can choose the timeout period. And then there's this option here for saving visualizations. By default, you might not need this if you're just looking for, say, the coordinates of the object that you're trying to detect, and you just need the kind of the information related to the detections. But if you want to be able to review the imagery with the visualizations on it, you'll want to check this so that you can look at that after the fact. And then from there, you'll hit Create Batch Job. Now, in the Roboflow app, there's another place where you can create a batch job, which would be in the deployments section, and then go to batch jobs, and then you can create a new batch job here. And then you can also select the workflow that you would like to use. And then from there, it's pretty much the same flow. So I have a batch that I previously submitted and has already finished processing. So we can take a quick look at that over here. And this is the video that I previously processed using my computer vision model with the batch processing. All right, and that wraps up our review of these three options for deploying your computer vision models in Roboflow Cloud. As you can see, we handle a lot of the hard part of provisioning not only GPUs, but also setting up the whole environment, managing the environment, so that you won't have to worry about that and you can concentrate on creating the best computer vision model and application for your needs.
Managed solutions aren't always suitable for all computer vision deployments. And so that's where Roboflow Inference comes in. Roboflow Inference is the code that we use to power our cloud. And you can run Roboflow Inference, which is licensed under an Apache 2 license, on your own hardware too. So if you do have applications that are latency sensitive, that require running offline, or where you have data residency requirements, you can get Roboflow Inference up and running and use the same code that we showed you earlier to manage your deployments, except on your own hardware in your own cloud.
All right, that wraps up our presentation about how to deploy your computer vision models quickly in the cloud. Thank you for watching. If you'd like to join one of our live sessions in the future, come over to roboflow.com/webinar.
Thank you very much, everyone.